Hello everybody, thank you for being here. My name is Alessandro Milite and I'm currently doing a PhD at Politecnico di Milano. Today, together with my colleague Riccardo, we're going to talk about our role in the development of the composite within the EOLIAN project. So as already introduced by the other partners, let's say that, of course, as you may know, composite materials are the primary choice for wind turbine blades, and within the context of the EOLIAN project, we want to develop wind turbine blades out of basalt fibers and a vitrimer matrix containing a certain content of bio-based materials. This kind of combination is advantageous from different point of views, especially from the sustainability side, allowing for better end-of-life management and also an extended service life of the structure thanks to the reparability of the vitrimer. At Polimi, we are actively working together with the other partners, focusing on the development of the composite materials. So our role starts from the composites manufacturing, and in this sense, we want to use the same techniques that are most widespread in the wind energy industry for manufacturing the blades. So we're talking about resin infusion, of course. Then we have a role into the testing of both the resin and the composite from the physical point of view, and this means both characterizing the basic properties of the materials and also performing, let's say, innovative tests in order to assess the vitrimeric behavior of the resin and the resin when it is included in the composite. And finally, our role is focused also on the development of end-of-life strategies that exploits the capability of the vitrimer to basically flow when heated above a certain temperature that is called the topology freezing temperature. So starting from the manufacturing, at Polimi, we started using a commercial vitrimer resin that is it was purchased from Malinda, a United States company, and this resin was really viscous. So for that reason, we could not perform resin infusion, and the first plates that we manufactured were done through hand layup. At the moment, we are trying to develop formulation that can be infused, and we are doing steps in this sense. And as you can see, this is the video of the infusion of one of the formulations developed in the project. And we did infusions both at room temperature, as the one that you see in the video, but also at moderate temperature, and in particular up to 80 degrees. Of course, there is a substantial advantage in the quality of the panels when switching from the hand layup to the resin infusion. So we believe that this is the road to be followed, and also this allows us to give feedback to the partners, to the chemical side partners, so the people developing the formulations, essentially because we may need a sufficiently low viscosity to get the infusion, but this will affect all the other properties such as the glass transition temperature and the vitrimeric character of the resin itself. Then from the material testing side, as I anticipated, material testing is divided into two macro categories. So on one hand, we have the characterization of the resin and the vitrimer matrix composite, and then we are focusing on the vitrimeric behavior. Now I leave the word to my colleague Riccardo.
Riccardo, you are muted.
Thank you. I was saying thank you, Alessandro. So for what concerns the first macro category, when we talk about the characterization of the vitrimer and the vitrimer matrix composite, we talk about the mechanical characterization of both the vitrimer resin and the composite material. So the identification of the mechanical properties such as tensile, flexural properties, but also the thermal characterization of the vitrimer resin. In particular, at Polimi, we are defining a protocol to identify this topology freezing temperature, which is the temperature above which the behavior of the vitrimer switches from the thermoset to thermoplastic behavior. So above which we can reprocess the material. We also focus a lot on the fracture behavior of the composite. As you can see in the video, this is a fracture test in which we investigate the interlaminar fracture properties of the composite laminate. We put a lot of focus on this direction since this kind of failure in composite material is quite widespread and leads to the decommission of the composite structures, and this type of failure is a type of failure which can be potentially repaired by the reprocessing of the vitrimer composite by closing the cracks and giving in structural integrity to the composite laminate. Next slide, please. The second macro category is the assessment of the vitrimeric behavior. So once we have a material that is developed by the partners, we have to assess whether this material is a vitrimer or not. So at Polimi, we developed a solid methodology that allows us to understand whether the material developed is vitrimer or not. This is done by the characterization of the vitrimeric properties such as repair, mechanical recycle, and reshape. Next slide, please. So just to give you an idea of the workflow that we follow, this is the workflow for the assessment of the reparability of vitrimer matrix composites that we are following right now. First, we perform a fracture test in which we induce the failure of the composite laminate by interlaminar fracture. Then we repair the laminate by applying heat and pressure, so activating the dynamic coupling bonds that characterize the vitrimer matrix, so that we can repair the defect, and then we test again the material. In this way, we can compare the results from the virgin material to the repaired one. And in this way, we can evaluate the effectiveness of the repair. Next slide, please. For what concerns the end-of-life strategies that vitrimer open to composite materials, since the material flows at high temperature, this allows also for the for end-of-life strategies that do not include the separation of phases. So one of the major challenges of recycling of composite is the separation of fiber and matrix. By mechanically recycling the composite, we can produce a sort of SMC of an SMC plate of a recycled composite vitrimer matrix composite, and also the reshape of curved part into flat panels in order to prepare the material for further property, for further processing or a secondary reuse is a valid option in order to give the the material a second life, an end-of-life scenario which does not include the separation of phases. So in this way, it is more sustainable. So next slide. Thank you for your attention. With this, our presentation is finished.